Okay, I wanted to go over a couple things um, with you. You know, as we've been working on converting everything over to database fed, one thing that I haven't done is updated you on where we're at with the database. And so what we've created so far has been quite the number of tables. This is a table that I didn't record that on here that I've created. We'll go over that table and we'll do a couple other tables, and I'll show you um, how this actually relates to the actual database that we have now. One of the good tools that Microsoft Management Studio has the ability to do database diagrams, and this is an awesome tool to use. Um, these are all the tables that we've created inside of our database, and although it's a bunch of tables, one of the good things is let's go ahead and just add them all in here. As you see, I'm adding these tables one by one. And that's a lot of tables. Okay. But when we click OK and we're done, what it does is it draws out all the relationships between them, so you can see where the relationships are. There's three tables rather that don't have any relationships assigned. It's world locations, and we haven't gotten to that. We will get to that. The table game audit, I will explain more in detail on that shortly. And then the item type. Okay, this I know has a relationship, and I'll show you that relationship on our grid here. We've got item type is somewhere in here. Oh, there it is. There's item type. And so we'll move it over here off to the side so you can see. But the item type ID relates to the item type inside the game items folder. And if we look inside the database, that relationship is not there. And so instead of actually creating a constraint through code and all that, we're going to use this to specify the relationship. And here's the game items. So if we take the type ID and we select the row like this, click and hold your mouse and come over here on the item type ID, you get this window and it says the primary key table is going to be the table games, as we showed here, which is the item ID. Is the here's the primary key. Oh wait, nope, my bad. The item type. Right? No, I messed that up. This needs to go to the primary key to relate to the primary key for these two. Alright. And then, or do I got that backwards? I think I got it backwards. Hold on, let's check this out. So if we, yes, I got it backwards. We want to go from the primary key here. You weren't supposed to do that. Come here. There we go. To the foreign key here. This foreign key is going to relate to this primary key. That's the relationship that these two share. So looking in here, let's cancel out of that. Let's cancel out of that. So the item type here is going to relate, and then click and drag. It's going to relate to that one. Primary key must be defined for table item type before it can participate in relationship. Okay. So it doesn't want me to do it that way. That's because this is not defined as a primary key. Although it is, theoretically, see how this one has a key next to it and this one doesn't? So it's saying, hey, you can't relate this to this because it's no primary key. And that's easy. We're going to do this all in the user interface. We're not going to do any coding with it. So we come over here to the item type, right click and go to design. And then once it finally loads, you got the item type ID, which is not a primary key. So we look up here and we can set primary key here. And it's set. Let's see if it'll let us save it. It let us save it. We'll close that, and then as you see here, now there's a primary key. So we take this and drag it over. Item type, type ID is primary key table, and then the foreign key table is the game items item type. And then here it gives you a drop down, and you can select any other item that will be in the table. And then you click OK, and now it creates it. But it don't just create a line here in the GUI. It actually creates, and let me double check. I might have to save it first. Without saving it, it might not actually save. So we'll go over here to game items, and let's look at the keys. Okay, so there's only one primary key. Constraints, no. Okay, so it ain't saved it yet. So let's go ahead and save the diagram. This is the diagram that we've built. This is the actual physical relationship that we've defined inside the database to get everything related. That's all the relationships that we've created along the way. We just forgot to, or I forgot, I keep saying we, but I'm the one doing it. I'm the one thinking it, so I'm the one that forgot it. I forgot to create the relationship between the game items and the game item type. So let's go ahead and save it. We'll click on the little save here, and it's going to ask to name it. Let's just try diagram 1. I mean, it's associated to the table. The following tables will have to be saved to your database, and the reason why it's doing that is because we added that foreign, or that relationship here. So now it's going to want to add that constraint of that relationship that we added. We'll click yes, and now we can go in the Object Explorer. Let's refresh the whole database, everything. Alright, not just the tables. We open the tables and go to game items. We can look at the keys, and now it shows that there's a foreign key, game items, related to the table item type. And that's the one that we added. And we didn't have to do no coding, nothing. We simply used this GUI here to be able to create that relationship to match the relationship that we built on Visio. And this is where coming up with the Visio is really, really nice to use. Let's see, let me delete some of these attributes here that we don't need, that I didn't delete earlier. That way they don't look bigger than they really are. Alright. Going down, going through, making sure. Alright. Now let's look at the new table that I added off screen. Alright. In it, I've added a bunch of items. Now it's old items, so every item's listed twice. We've got old item all the way down to old type, and then we also have new for each of them all the way down to new type. We have the update date, and we have a user updated. Let's close this out. And what we're going to do is I'm going to show you this table. Alright, so let's just right click, select 1,000 rows, or top 1,000 rows, and what this is going to do is it's going to show the table. Okay, now this is something that's automated. I don't do it automatically, or I don't do it manually. I don't tell it to do it. I just said, hey, when this event occurs on this table, fill in all these values, and that's referred to as a trigger. A trigger is something that happened. It triggers when an event occurs, whatever event that you specify, and I specified on update. So when I update a new item, and only update a new item, does the trigger fire. So let's go in here and let's look at the trigger. Actually, I'm going to go ahead and delete everything first. So let me grab this, and we're going to delete everything first, all 12 rows. Good, done. Run it again, there's nothing in it. No, we don't want to save that. That was just a temporary thing. Alright, what was I going to show you? Oh yes, I was going to show you the trigger. Alright, now in the game items table, under triggers, you'll see that I've got a trigger update game items. We'll right click and modify that. And in here, we're doing a select into statement is what I refer to it, because you're inserting, and it's a term that a lot of database admins use is a select into, and here's all the values. Now I get these values from two tables. When you insert, update, delete, SQL Server generates two sets of data: the new data that you're inserting and the old data that it's replacing or deleting. And so if you look down here where I specify the from clause, you see that the table that I'm grabbing from, which would be a temporary table, is from the inserted table. And then also the second table is the deleted table. The table in deleted is the old data. Okay, and knowing this will come handy later on. There's some things I haven't gotten to yet that knowing this information is very, very good to have. So by using these two tables that SQL Server generates, we can get all the changes. So we can get all the original, which I specified as old. We can get all the original data. Then we can get all the new data that's replacing it. We can get when the update occurred and who the update occurred by. And we specify outside of these two tables, these are built-in functions inside SQL Server. Get date gets the current date and time. That I mean, like if I hit it right, it'd be right now. And I'll show you. Select get date, and if I do this, it'll tell me that it is what's for January, February, March, April 5th, 2020. And as you see here, it's military time, so that's going to be 8 o'clock. Normally, it's just easier if it's above 12 o'clock in the day. If you subtract 12 from this, that's going to give you the actual time that it is. And then use your common sense to figure out whether it's morning or evening for AM, PM. One of the ways that I do it is I subtract, I do two separate transactions, like 20, minus 2 is 18, minus 10 is 8, so I drop off that 1, and it's 8 o'clock, simply by minusing 2, drop off 10, minus 10. For me, that's easier. I mean, that's just for me. But I just wanted to show you that, and that's what the get date function is. It'll get the current date and time of the server, and in the system user, anytime it gets the current person logged in to that session. Not to the server, but to the session on that server. See, it's showing you that I'm the person that's current. It is my session, and because it gets the current user of the current session, we can find out and know who actually performed the update. So if you're in a big company, a big business, and you want to monitor your audits and you want to make sure that you're documenting every single change, who did it, when they did it, and what they changed, this is one way that you can do that. And I'm going to show you real quick. No, we don't want to say how it actually works. And I can do that by coming over here to Solution Explorer. I'm just going to right click and go to Open Folder and File Explorer, and then just dig in the bin, the debug, and start the actual executable itself here. So I can take and I can say, let's do the Snake Fang. Minimum damage is 100, maximum damage is 150. You know, and we update it. Alright, now it was a Snake Fang. So we can come back over here to the database, and right here in the game item audit, we select it, and there it is. There's the old item ID, the description of it, the minimum damage it was originally at, the item type. And so what we changed is we changed the minimum and maximum damage. The rest of these are going to match these right here, all the way down here, and then that one. But these two, here and here, as you see, they contain the old values and then the new values that I entered. And so then we can document and audit this completely in itself. And let's see, I created a stored procedure earlier today, and I wanted to go over it, just kind of give you some background. I just have to remember which one it was. Maybe it was update weapon. Yes, okay, so I wanted to go over this with you because something that we haven't done yet is perform transactions. And transaction is what actually occurs. I haven't been specifying it with the select statements because I'm not modifying no data. I haven't really been modifying data through the program up until recently. But what it does is it captures this transaction and it kind of puts it in a container. This is how I think of it. Now, people out there might be like, well, hey, you're wrong. You can't think of it that way, but it works for me, so back off. But anyways, we get a transaction. We begin a transaction, right? We specify it. And then we come down here and we perform the functions that we want to function. Alright, and if anything goes wrong in this, for some reason it doesn't accept the minimum damage, but it takes everything else. But there's an error that occurs within this. Well, we need to remediate that. Say like this select statement returns null, so it's going to put null there, or it's going to error out and say more than one item was found, like we got 2 rows of weapons, and it's only looking for one, because that's what we're looking for, right? We're looking for one type ID, because we can't store multiple values that have two different meanings in one table. It doesn't work that way. If we got a 1 and a 2, they're two separate values, and they won't ever live together in one object. So we get down here and we say, hey, hold on, was there any errors? If there was an error, if the error is not equal to 0, then we need to go to our problem, function, and then here in a problem function, we're going to start the if statement and begin. And the first thing that we're going to do is I want to select -1, and this returns a -1 to the database, or to the program, not the database. So it's going to say, hey, grab this -1 and send it. Okay, and that gives us the ability to do some checking in our program, saying, hey, was there an error? Without throwing out a massive error, we can create a custom error for it that explains it. We'll get into that shortly. Or if there was no error, we want to go ahead and select 0 and commit the transaction. But if we have the error, we want to roll back the transaction. And this way we don't put insert no bad data, no bad insert statement will stay in the system, at least from where we specified here to here. There won't be no bad data that occurs in the database from here, because it's going to say, oh, hey, look, but I did do something wrong, and I don't have to specify this. And we don't have to specify this because, oops, hold on, go back. I took out the problem function. Alright, so what we do is, I'm going to switch it to this because I actually never assigned that variable to error, which is what it signifies. So if this is not equal to 0, the error in the transaction is automatically assigned to 0. That's default, no error has occurred value. Okay, and then this is the error code. The 0 is actually the error code that gets thrown for whatever error occurs. We don't care what error occurs, not as a user using this interface. Because as a user, if the code doesn't work, we need to tell the coding department, hey, your stuff's messing up, we need you to fix it. And they'll look into it, and most of the time they'll give a generic error, but they'll be able to have some identifiers in it to find out where the error's occurring, because you don't ever want to return the database default database errors, not to the user. You always want to create custom errors to do that. Let's go look at the code and see if I've implemented this to check for that. So we'll come over here to the update button. We'll right click, outlining, collapse definitions, and that collapses everything within that window. And we're going to update button click is what's related to the stored procedure. So SP update weapon, yes, that's the right stored procedure that uses the transaction. And we'll come over here and see, this will never happen. That's what the returned value is. We'll get to that in a minute. but if return value is equal to null, throw this error, but that's not what we told this. Here we want to say, hey, if it's equal to -1, we want to throw an error. So we'll come over here and we'll change null to -1. Now by default, what is it? Okay, dot to string. No, don't. There it goes. Okay. And so we've got a new function here, and it's called, and I named it update data, and that's where we'll always use update data, because I plan on intending on moving this code here, always using this section here and this section here on every data manipulation, known as DML, data manipulation language. It's the update, insert, delete, anything that modifies data. Selecting data is known as a DDL, selecting and stuff like that. Getting data is DDL, modifying data is DML, in case you want to know the difference. And in some cases, if you're going for certifications and things like that, that's kind of the stuff you do need to know, because they will try and throw you off by throwing in, which one's a DDL or which one's a DML, and they try to throw you some trick questions in some certifications and some school classes, and sometimes you need to know the difference between the two. And I use it in my work all the time. So it's not just for that either. You're talking with a database developer or administrator or something. They're going to use that kind of language as well. It is something that is used. Alright, but that's all I really wanted to go over. I didn't really want to get into coding a whole lot. I just wanted to kind of catch you up to speed on the database. I wanted to check the relationships using the database diagrams. Like I said, you just go to your diagram, go to your database, and then in your database, go to your database diagrams, and then you can open it up, and we can zoom out and get a full picture of what we've created so far. Sorry, my graphics card really stinks, so it doesn't help out a whole lot. But this is the structure that we have so far, and as you've noticed, game items is like the central point of the entire game, right? Because you got traders, you got players, you got mobs, you got and they're all based off of. Let's move you up here, move you out of the way so we can see a little better. We'll move you there. Okay. And so you have a lot of different things. Okay, there's my other two tables that could be in it, but this is definitely a highly recommended tool to use. There we go. I like to try and keep my stuff organized near the top like this, just because I don't know, because this is really an infinite amount. I mean, I could go way down here and just go, and I go way over here. So it'll continue expanding as far as I want, but just to maintain the smallest amount that I can, I like to keep everything close together. Alright, anyways, I hope you learned something. If you have any questions, feel free to ask. I don't mind answering. PM me, message me, call me on the phone, whatever you need. But you have a good night. Tomorrow's Monday. You know how those days go.